Come back, guys. So in this video I'm gonna solve a problem from rotational mechanics. So this is a very important problem you may have seen in many books and other sources as well. So before watching the problem solution, pause the video for 1 to 2 minutes and solve it. So and check out the problem solution. So you will find something really new in this problem. So watch till the end. So let's begin. So in the problem, a plank of mass m1 with a uniform solid sphere of mass m2 placed on it rests, and then the force F is applied to the plank. The acceleration of plank, provided there is no sliding between the plank and the sphere. So it is the key word of the problem, is F by m1 plus n by 7 m2. So the value of n is, so before doing the solution, so you understand what the question is. So this is the plank, this is the solid sphere. In this, there is no sliding between both of them. So this is the key word. So what is the meaning of no sliding between the plank and the sphere is, so both the bodies move together. So there is no relative motion between the point of contact. So here, there is a point of contact. Here the no relative motion. So actually, I'll write here. So this is the sphere and the plank. So it will rotate anti-clockwise with the angular acceleration alpha. So this is the direction of angular acceleration alpha. Okay. This is the direction of center of mass of the sphere ACM. Yeah. So this is the acceleration of Planck AP. We assume it AP. So okay. All right. Next, they write FBD of the Planck. So there is the static friction between both of these. So this provides no sliding between the plank and the sphere. So friction, basically the force is applied on the plank in the rightward direction. So the sphere will tend to move backside. So on the sphere, the friction will act in the right side motion. So I represented here. So if the friction act rightward in on the sphere, this, so it will have a opposite reaction on the plank as well. So yeah. So after writing the FBD of the plank, so for force F on the right side, friction backward F, so it's moving with acceleration AP. So for, same for sphere, acceleration of sphere ACM, center of mass. So angular acceleration alpha, friction F. So this is the main equation I wrote here. So the relative acceleration is 0 between point of contact. All right. Next, we write the equation of torque. So it is the instantaneous axis of rotation. If we write torque about this, the friction will not in the equation. So we want friction in the equation. So F dot R equal to I alpha. So moment of inertia about center of mass is 2/5 mr square into alpha. From this we got the friction value. Friction equal to 2/5 m2 into r alpha, equation 2. So on the sphere, F equal to mass into acceleration. So basic equation 3. So for Planck as well, we write capital F minus friction equal to m1 into acceleration of Planck, equation 4. So after basic calculation, solving 2 and 3, we got acceleration of center of mass equal to 2/5 r alpha, equation 5, from 4 and 5. So in the fourth equation, fifth equation. Okay. F minus m, in the place of friction we substitute mass m2 mass into acceleration of center of mass. In the place of center of mass acceleration, substitute 2/5 r alpha. So from this we got value of r alpha here. So from equation 1, so in this we substitute r alpha here. So after doing calculation, we got acceleration of Planck equal to F by m1 plus 2/7 m2. So from this we got the value of n equal to 2. So it is an interesting problem, an important problem for JEE Advanced. So yeah, thanks for watching. If you really like it, like the video and do subscribe. We will meet in the next video. Yeah.